Hello geometry students, and welcome to section 10.2 of our geometry course. And you see we have arc length being discussed today. And the good news, after our long video for 10.1, this is going to be a very short and straightforward video, because we mentioned in section 10.1 that arc length can be measured in two ways. It can be measured in degrees, and you did that on your previous homework assignment, where you talked about how if the central angle was 80 degrees, then the arc measured 80 degrees. And that told you what part of the circle. But today we're actually going to start talking about it as a fraction of the circumference, an actual length in units, where we're going to say, if you took that arc, cut it out, and laid it flat, how long would that section be in inches, or in feet, or in meters, so on and so on. We're going to give an actual distance measurement today. We're only going to do one example of this because all the problems are going to be the same. It's going to be a little bit challenging because of this, big old F word we see right here. And I know this F word causes problems with some of you, but we are going to be working with fractions. You are welcome to use calculators. Your calculator will do the fraction work for you. But all we're going to be doing today is finding fractions of the circumference. So here we go. Our one and only example we're going to look at today is here on the right side of your screen, where we see an arc, and it wants to know the length of this arc here that is bolded in, and it wants to know the length of that arc in bold. So to do that, we're going to go ahead and talk about it as the fraction of the circumference of the entire circle. So remember, circumference by taking pi times diameter. So in this case, your radius is 11, which makes the diameter be 22. So our circumference is 22 pi. We're going to do all our answers in terms of pi today because we're going to have a lot of fraction answers, and we want to avoid mixing our fractions and our decimals. So we're going to leave our answers in terms of pi, just like you're familiar with from last chapter. And we're going to go ahead and calculate what the bold region would be, the bold arc is in units, in this case in meters. So the circumference is 22 pi meters. That means the distance all the way around the circle is 22 pi meters. We want to know just the bolded section of that, so just this part here. So in order to find the length of that part, we need to recognize that that's a fraction of the whole circumference. And that's 150 360ths of the whole circle. Because a whole circle is 360 degrees, and we know the arc length is equal to the central angle. So therefore, if the central angle is 150, the arc length is 150 degrees in degrees. But if we want to find that actual measurement in meters, we simply take 150 360ths times our circumference, which is 22 pi, and I'm going to write it over 1 just because we're working with fraction. A lot of you like to see a fraction times a fraction. So in order to find half of something, you multiply by half. If we want to find 150 360ths of something, we multiply by 150 360ths. So I'm going to go through how I would approach this problem on my own first, and then I'll go through other options for you. So in order to calculate this out, I'm first going to reduce this fraction, 150 over 360, and say I can divide them both by 10, making it 15 over 36. Then I recognize 15 and 36 can both be divided by 3, getting us down to 5/12. All right, now we have a fraction multiplication problem. Just like we've done in our skills quizzes all year long, we can reduce anything on bottom with anything on top before we multiply, and our final answer is 55 pi over 6 meters. Now, that's actually doing out all the work by hand, not using a calculator, just figuring out what we do to figure out this fraction of our circumference. If you want to do this in your calculator, you can do this using the ABC button in your calculator, and it'll do all the work for you. If you just type in 150 ABC 36, 150 ABC 360. So you're typing in the fraction 150 360. Then you just times by 22. It'll do all the work for you, and it'll give you your answer, 55 pi over 6. So the more difficult part of this isn't going to be the arc length. It's going to be working with the fraction. We want to leave our answers in terms of pi. We want our answers labeled in a unit of measurement because we're talking about an actual measurable distance. And the challenge comes from reducing the fractions. All right, that's it. We did it in 6 minutes. Have a great day and good luck.